All right, y'all, we're taking a look at the 1-7 notes. 1-7 talking about solving absolute value equations. So I want you to think for a second about absolute values, okay? What an absolute value actually means. This is something you probably learned about in middle school math, and the way that an absolute value is defined officially is talking about how far is a number. If you put a number on a number line, how far is it from 0? So, like, for example, the number 6 is 6 away from 0 on a number line. And so positive 6 has an absolute value of positive 6. Well, it also goes the same way if you're looking at a negative number. So, like, the number -8 is 8 spots away from 0. Okay? So an absolute value of -8 gives you positive 8, okay? Because that's how absolute values work. It represents a distance, and something you learn in geometry is that a distance is always a positive number, okay? It doesn't make sense to say that I'm -3 feet away from that desk, or I drove -4 miles. A distance is always positive, so that means an absolute value is always positive. Now, there's something that you know about that, though. Okay, something that comes up because of this is that a number and its opposite have the same absolute value. So meaning, if I were talking about the number 6, okay, the absolute value of 6 is 6, but the absolute value of -6 is the same thing, okay? In fact, that's what this example is. This example that's given on the front page of the notes is talking about an equation. This is a very simple absolute value equation, and it's asking you to solve for x if the absolute value of x is equal to 5. Well, we already know that if x equals 5, then that would work. Okay, if x equals 5, the absolute value of 5 is 5. But x could also be -5, because the absolute value of -5 is also 5. So instead of just saying x equals 5 and we have one solution, we have two possibilities. We say that x is part of that set. It's either -5 or +5, because either one of those would give you a true equation. So the reason that we're going through all of this is because it is possible to look at all these equations that we're going to do today, and you're going to come up with two solutions for all of them, okay? So we're going to follow these steps right here that are they're printed off on your page right there. Okay, I want you to go ahead and put a star next to number 1. Okay, how to solve absolute value equations. The first step of this, the very first step is always the most important part. You're going to do it on every single problem, no matter what, including some of the special cases that we're going to talk about. Okay, after we've isolated the absolute value part, we're going to split it into two separate equations, and I'll show you what that looks like. After that, it's just checking your solutions. Step number 4 is going to be a special case. Okay, so this right here is a special case. It's not going to happen very often, but when it does, it will always follow the rule that's given. Okay, so let's look at our first example. Our first example right here says 2 times the absolute value of x plus 6 equals 14. Well, when I look at that 2 on the outside, and 2 is placed directly next to something, it is very tempting to look at this and try and go, well, turn that in, distribute it, right? It's very tempting to do 2 times x and 2 times 6 and turn that into 2x plus 12, but we can't do that, okay? On all of these with a coefficient in front, do not distribute anything. Okay, it is very important that we do not distribute anything, because those, the absolute value, okay, those vertical bars, those are not parentheses. Okay, they don't work the same as parentheses. Our step number 1 for solving any of these equations has to be to get the absolute value part by itself. We want this thing right here to be completely isolated. So what we're going to do is we're going to divide by 2. We're going to get rid of that coefficient by dividing it out. That goes away. The right side of your equal sign becomes +7. And you've got just the absolute value part, x plus 6. Absolute value of x plus 6. The second step After we have that absolute value part completely by itself, what we're going to do is we're going to split this into two separate equations. Okay, one of the equations looks like this. We've got x plus 6 equals 7. The other way we split it is x plus 6 equals negative 7. Okay, this is all because we know that 7 and negative 7 have the same absolute value. So if we can find the two x's that make this equal to 7 and negative 7, those are the two things that we could plug into our original equation up at the top and give us solutions. Okay, these two x's will be solutions to our original equation. And it turns out to be really simple to solve these things, right? We're just going to subtract 6. Remember your golden rule of algebra: what you do on one side of the equal sign, you have to do to the other. So x equals 1 for that equation. We subtract 6 on this one. We get x equals negative 13. Okay, what that means for us is that either of these two answers, x equals 1 or x equals negative 13, would be solutions to our original equation. Okay, and if you're not sure about that, plug them back in. If you plug in 1 right there and turn that into, turn in our original, if you look at our original and try to plug in 1 right there, well, that becomes 1 plus 6. Well, that's 2 times the absolute value of 7, which fits. Okay, that is equal to 14. If you turn that into negative 13, then you get 2 times the absolute value of negative 7, which again fits in that equation. Okay, that right there was just checking my answers. So we've got two solutions: x equals 1, x equals negative 13. And what I'm going to do is I'm going to put those into a set. Okay, just like we did up here, what I highlighted right there. We're going to put both of our answers, our final thing, x is a member of this set. It's either negative 13 or positive 1. It's either of those two options would be a good answer for what is x equal to. All right, roll on over to example number 2. Example number 2, we've got something happening to our absolute value part. Remember that the first thing we want to do is always get this thing completely by itself. So the question, how do we get rid of this minus 3 at the end? We're going to add 3. Okay, all of that gets simplified down. Everything over there goes away, and we just have the absolute value part. On the right side, it's equal to 16. Now, after we have it isolated, after we have completed the first step, that's where we split it. The positive version is 2x plus 6 equals positive 16. The negative version is 2x plus 6 equals negative 16. Okay, and we're going to solve for both of these different x's. We're going to subtract 6. 2x equals 10. That's pretty obvious. X equals 5. And on our other side, we subtract the 6. 2x equals negative 22. We divide that 2 out the same way. X equals negative 11. So we take those two solutions and we put them in our set notation. X is either negative 11 or positive 5. Okay? On a lot of these questions, the solutions that you're going to get, there will be one positive and one negative. Not every time, but that's going to happen a lot. You're almost always going to have two solutions. Okay? What I want you to do right now is I want you to take a try at number 1 and number 3 on your own, and we'll compare your answer to my answer here in just a minute. Okay? So give number 1 and number 3 a try on your own, and then I'll pull up the answer on here. So here's what I got for number 1. I got solutions of negative 6 and positive 2. You can see how I solve those equations one step at a time by subtracting 12 and then dividing by 6. On number 3, to solve those equations, I had to first get rid of the plus 1 in our original. Okay, remember that your first step is always to isolate the absolute value. So then when I split it, I solved those equations by adding 2 and dividing by 4. Came up with solutions of negative 10 and positive 11. Okay, Real quick, I want to go over number 5 and 6 also. You can do number 3 and 4 on your own. Okay? Number 5 and 6, or excuse me, number 2 and 4, you can do on your own. Look at number 5. On number 5 right here, I see a 2 out in front of our absolute value part right here, okay? This right here, starting there, that's what we're trying to isolate. This 2 is being multiplied, so what we need to undo is we need to divide it. Okay, we divide it on out of there. We have our absolute value of 10 minus x equals 8. Okay, and then we split it. The positive version, 10 minus x equals positive 8. The negative version, 10 minus x equals negative 8. Okay, so if we're trying to solve these equations, we're going to have to get rid of this positive 10. That gives us negative x equals negative 2. Well, if negative x equals negative 2, positive x equals positive 2. Excuse me. Same thing over here on the other one. Negative x equals negative 18. Positive x equals positive 18. So the reason I wanted to point this problem out, the reason I wanted to draw your attention to number 5, is because unlike those other problems, on all of the other problems that we've done up to this point, we had one negative answer and one positive answer. Okay, that is not necessarily going to happen every single time. Okay, because the math on this problem number 5 just told us that we have 2 positive solutions. It's not necessarily going to be opposites every time, okay? Just wanted to point that out, that sometimes you get 2 positive, sometimes you get 2 negative answers. That's just how it's going to go. Last one to look at is problem number 6. Now, problem number 6, what I wanted to show you on this one is our special case. Okay, you'll remember from that front page, we pointed out that step number 4 was a special case, and usually you don't have that. Okay, what happens on problem number 6 is something very particular, very peculiar. Okay, you can see that we have the absolute value part already isolated. It's already completely by itself. But I want you to think about this, okay? The way we defined an absolute value was that it's a distance. Okay, it's a distance in between a number and 0. Okay, and we also, when we were talking about distance, and this is how you talked about it back in geometry too, you wouldn't say that you're negative 3 feet away from something. You wouldn't say that you drove negative 4 miles to get somewhere. Okay, a distance is always a positive number. So how in the world, I ask you on problem number 6, how in the world is the absolute value of something going to be a negative number? How is the distance between that thing that's highlighted and 0 going to be negative 36? And the answer is that it's not negative 36. In fact, there is no distance that's negative 36. What this is telling us is that we have a solution, or we have an equation that does not have a solution. Now, on your homework assignments, and as you're working on this, just because you have a negative number over here doesn't automatically mean that it's going to be no solution. Okay? The reason we put a little star on these instructions next to number 1 is because you always have to do that. Okay? There is no time in which you skip step number 1. You have to make sure the absolute value is isolated before you can do anything else. Now, on number 6, that problem we just did at the end, the absolute value was already isolated. Since the isolated part was equal to a negative, that's why we say no solution. But if it's not isolated yet, make it that way and then check if it's going to be no solution. All right? Don't automatically write it off just because you have a negative sign, because sometimes you will end up dividing that negative out of there and you have a positive one that does have possible solutions. Okay? Just something to watch out for. That's going to be all of the notes today. Hope y'all all have a good one.